So finishing up where we left off in class, I want to review what A and B does. So A just multiplies the Y values by A. Now B divides the period by B. Now we know that a normal period is 2 pi, but we're going to divide it by B to get the new period. So if we have y equals 2 cosine of 3x, that means that I'm going to take every normal y value and multiply it by 2. This means that I expect my max value to be 1, which is the max value of cosine, times 2 is 2, and the minimum value to be negative 1, because minimum value of negative 1 of cosine is negative 1, and then multiply it by 2 to get negative 2. So I expect, and in fact I'm going to go ahead and label this as 1, 2, negative 1, negative 2. I expect it to max out at 2 and min out at negative 2. Now, let's figure out the period. So if it's 2 pi over b is 2 pi over 3. So this is my period. So this means that it's going to repeat every 2 pi over 3 radians. Now this is kind of interesting. So, I haven't actually graphed anything yet, but the idea is that if this goes to 2 pi, well, if the period is 2 pi over 3, I actually expect to have 3 rotations, right, or periods or copies on this graph, right? So let's think about some key points. So if cosine of 0, right, if I just plug in 0, I get 3 times 0 is 0, cosine of 0 is 1 times 2, so we expect it to start off at 2. All right, that looks good. So how about, when is it going to be 0? Well, if we think of our normal special points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, we've now taken all of them and divided them by 3. So now they are 0, pi over 6, pi over 3, 3 pi over 2 divided by 3 is just pi over 2, and then 2 pi over 3. So these are our new special points. So this means at pi over 6, I'll just go ahead and call this pi over 6, we expect it to be 0 because it's 0 at pi over 2. Now at pi over 3, we expect it to be negative 1, right? And then at pi over 2, we expect it to be 0 again, or sorry, negative 1, and then multiply it by 2 to get negative 2. And then at 2 pi over 3, so let me write pi over 3, 2 pi over 3, we are back at 0. So our function looks something like this. So it is pretty skinny. And if we were to keep going, we'd end up with something that looks like this. And you end up with 3 full cycles or periods of or rotations in this. And the reason why is because we're repeating every 2 pi over 3, and you can fit 3 2 pi over 3s in a length of 2 pi. So what we did, just to kind of take a step back, is we took our special points. Our special points are, you could include pi over 4 if you wanted as a special point. Pi over 6 and pi over 3 are definitely a little more complicated. But the normal special points are going to be these 5 right here. And you take them and you do to them what you've done to the period. So we took the period and we divided it by 3. So we're going to take all of these and divide by 3. And then they just match up, right? 0 goes with 0, pi over 2 with pi over 6, pi with pi over 3, 3 pi over 2 with pi over 2, and then 2 pi with 2 pi over 3. And that gives us our first piece of the graph, and then we just keep on going. Now, each of these divisions along the x-axis are what? Well, so if our normal, let me go back up to our original here. If our normal important division, right, is pi over 2, then what happens is we're going to take that pi over 2 and divide it by 3, right? And that gives us our first point, obviously, is pi over 6. But we can see that each time I now move each special point, right, which normally moves by pi over 2, 0 to pi over 2, plus pi over 2 is pi, plus pi over 2 is 3 pi over 2, and again, plus pi over 2 is 2 pi. So the special points jump by pi over 2, but we've now divided the special points by 3, so our new special point jump is pi over 6. So we have 1 pi over 6, 2 pi over 6, 3 pi over 6, 2, 3 pi over 6, and then 4 pi over 6, 5 pi over 6, 6 pi over 6. So this right here, if I wanted to, would be 7 pi over 6. This would be 8 pi over 6, which is 4 pi over 3. And then 9 pi over 6, which is 3 pi over 2, and so on and so forth. So the idea is that we could, write down what all of these points along the x-axis are. So I'm going to write this real quick. So we'll say we take the special points and divide it by 3. So a normal jump, so a normal special point jump is pi over 2. So now we're going to divide it by 3. So now the special point jump is pi over 6. All right, so in this case, our A is 2, right, up here. Our B is 3. What's our amplitude? So remember, our amplitude is the height of the wave, or the absolute value of A. In this case, it's just 2. The period we already determined is the normal 2 pi divided by B, so 2 pi over 3. Now, was there a reflection? In this case, there was no reflection, right? Even though it's smushed, it's compressed along the x-axis, it actually looks just like our normal one. It's not flipped or anything like that. So the reflection is going to be no. So our start x is 0, and the end of our first period is 2 pi over 3. Okay? So we have now a equals 1, b equals 1, so we get y equals negative cosine of x. So that means the period doesn't change, right? So the period is 2 pi over b equals 2 pi over 1, which of course is just 2 pi. So our period doesn't change. Now that means that we expect the length to be the exact same, right? It's not compressed or pulled apart or anything like that. But with this a of negative 1, we're going to flip it. So normally when cosine of 0 is 1, but because we now have a negative out front, it becomes negative 1. Pi over 2 is 0. Pi, cosine of pi is negative 1, but we flip it because we have negative a. 0 at 3 pi over 2, and then 2 pi normally is 1, but now we flip it and it's negative. So this looks just like our graph from before, but it's been reflected. So we'll say it has been reflected, the period hasn't changed, and the amplitude is still 1, right? The period hasn't, or the amplitude hasn't actually changed. It's been reflected, but the amplitude is the height, and this height is just 1. So we're going to start at 0 and end at 2 pi. So we'll do 2 sine of 2x. So from this, we know the amplitude is 2. The period is 2 pi divided by 2 equals pi. So now I'm going to take my special points, which are 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Now I'm going to do the same thing to my special points as I did my period, right? So that I can figure out what my graph's going to look like. I'm going to divide it all by 2. Divide by 2, and I get my new special points are 0, pi over 4, pi over 2, 3 pi over 2, and pi. So I need to change this graph up a little bit. I'm going to put right here a pi over 4. I'm going to put right here a 3 pi over 2. And I know my amplitude is 2, so it's going to max out at 2 and min out at -2. Now, cosine of 0 is 0. 2 times 0 is 0. So we get 0 right here. And then at pi over 2, it's 1, but now it's 2. Pi over 2, it is, at pi, it is 0, and now that occurs at pi over 2, so we get 0. 3 pi over 2 will be at -2, and then pi will be back to normal. So what's our jump? So our jump is normally pi over 2, but now we've divided it, so our new jump is pi over 4. So that allows me to go through here and say, all right, I can do, this is 4 pi over 4, so this is 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 2 pi. So it should look like this. Bingo. So this is what we expected, right? If we took the period and divided it by 2, and the normal period is 2 pi, we expect that on a graph that goes from 0 to 2 pi to be able to graph it twice. So in this case, the amplitude is going to be 2. The period is going to be just pi. It's not reflected, and it ends at 0, starts at 0 and ends at pi. In this case, our A is 2, and our B is also 2. All right. So we now have something that's a little bit more interesting. Cosine, or y equals negative cosine of 1/4. So in this case, A is -1, B is 1/4. So the amplitude is the absolute value of our A coefficient, which is just 1. What happens to the period? Okay, so the period is 2 pi over B is equal to 2 pi over 1/4. Now remember, when you divide by a fraction, you multiply by the reciprocal. So this is actually equal to 2 pi times 4 over 1, which is actually equal to 8 pi. Okay, that's pretty interesting. So we took our period and we multiplied it by 4. So let's do some special points. So our special points are normally 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Now we're going to take all these and we're going to multiply them by 4, because that's what we did to the period. So our new special points are 0, this is 2 pi, 4 pi, this is 8 pi, this is 12 pi over 2, so this is 6 pi, and this is 8 pi. Right? Yeah, 0 times 4 is 0, pi over 2, that's 4 pi over 2 is 2 pi, 4 pi, 12 pi over 2 is 6 pi, perfect, and then 8 pi, 2 pi times 4 is 8 pi, we got it. So the period is 8 pi, and again, that's what we expect because this final value should, of course, be equal to our period if we start at 0. And so we'll say we start at 0, we end at 8 pi. Is there a reflection? Yes, there will be a reflection. Things are, because it's -1, so we're gonna, flip it. So I'm gonna put 0 right here. I'm gonna put 8 pi right here. Here in the middle, I'll put 4 pi. Here I'll put 6 pi. Here I'll put 2 pi. Now normally we'd start off here, right, at 1, but it's flipped, so we're gonna start at -1. So -1 to 2. Now 4 pi normally would be -1, but it's flipped, so we're going to go up to +1, back down to 0, and then down to 8 pi. So it looks something like this, assuming I can make it look nice. Yeah. So, spacing's a little, I guess maybe it would be better to put this one. Yeah, maybe this should be over right here. So we get 6 pi. That looks nicer. Yeah, there you go. Okay. That looks more like the shape we were expecting. So this is what the graph of negative cosine of 1/4 would look like. So again, it looks just like a regular graph reflected across the x-axis, right? Flipped, but because we now have this, b value that's less than 1, when you divide by something that's less than 1, it's actually, makes it bigger. So our period has been elongated, right? If you think of, this being our period right here, it's been elongated. It's been pulled from just 2 pi all the way to 8 pi. All right. So final thing right here, we've been starting with a function and graphing it, but can we go the other way? Well, answer happens to be yes. So what equation could this be? Well, right off the bat, we can say that sine should start at 0 and then max out at 1 and then min out, or excuse me, and then back to 0 and then min out and then back to 0. So it starts at 0, maxes out, goes back to 0, mins out, and then is back to 0. This is not what we have. Our function, it looks shifted. So what does that mean? Well, this looks like cosine, right? Because cosine begins at a minimum or a maximum and then goes to 0, right? Goes to 0 and then to a min or max, back to 0, and then to a min or max. So we can tell from the fact that this started off at 0, excuse me, this didn't start off at 0, it's not going to be sine. It started off at a min or a max, so it's going to be cosine. So I have cosine of something. Now, what's the amplitude? Well, the distance right here is 2. So our amplitude is 2, but normally we expect that cosine begins at 1 or begins at the amplitude, right? In this case, it should begin at the positive amplitude. So it should begin at 2, but the fact that it begins at -2 means we have a negative in front. Okay, fantastic. So now what is the period? So if it begins at -2, the next time it returns to -2 is at 4 pi. So the period is equal to 2 pi over b, and this is equal to 4 pi. So what does this mean? Well, I can solve for b and say 2 pi, I'm going to write this right here, solve for b. So I'm going to multiply across, I get 2 pi equals b times 4 pi, and then I'm going to divide both sides by 4 pi, giving me b equals 2 pi over 4 pi. My pi's are gone, and I'm left with 2 over 4 is 1/2. So I get 1/2 x. Now this is what we expect, right? Because remember that the things that are in the argument do the opposite of what they normally do, right? If we're dividing by a number, this means that the period gets larger, right? Or in this case, multiplying by a number less than 1, of course, is the same as dividing. And so it would normally make it smaller, but because of the fact that it's in the argument, as we showed before, it actually will stretch the period. So we expect that because the period has been stretched, we expect that b is a number less than 1. And in fact, we get b is 1/2. So let's go ahead and fill this in. We know that this is cosine. We know the amplitude is 2. We know that a is -2. The period is 4 pi, and b is 1/2. So the equation is -2 cosine of 1/2 x. All right, so remember I said that these two functions, this green function and this blue function, look kind of similar, right? In fact, it seems like there's some kind of distance between the two of them. And the answer is yes, they are shifted images of each other. And to show you that, I will do cosine of x minus pi over 2. So what happens if I do cosine of x minus pi over 2? So remember that whatever's in the argument, we do the opposite to it. So I'm going to take these special points, which are 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And I'm actually going to add pi over 2 to all of them. So my new special points, right, in the same way that whenever I had multiplied by b, I divided, b in the argument, I divided the period by b. It's the opposite of what you expect to do. So my new special points become 0 plus pi over 2 is pi over 2. Pi over 2 becomes pi. Pi becomes 3 pi over 2. 3 pi over 2 becomes 2 pi. And then 2 pi becomes 5 pi over 2. Now, let's graph this and see what this looks like. All right, so I have 0, pi over 2, pi, 3 pi over 2, 2 pi, and then 5 pi over 2. Okay, so normally at 0, cosine is 1, but now this is occurring at pi over 2, so cosine is 1. Normally at pi over 2, cosine is 0, but this is now occurring at pi. Normally at pi, cosine is -1, but this is occurring at -3 pi over 2. Oh, let me do my margins correctly here. Or not margins, my graph correctly. So -3 pi over 2 is at -1. And then normally at 3 pi over 2, cosine is 0, but this is now occurring at 2 pi. And then normally at 2 pi, it should be 1 again, but this is now occurring at 5 pi over 2. So this is our graph of cosine, which looks kind of like what we expect. But what happens if I were to add an extra point in here? Call this negative pi over 2. Well, my new special point is going to be 0, isn't it? Because I added pi over 2. So cosine of pi over 2 is normally 0, right? We imagine we have our unit circle and we, right? We go this direction. So this would be 0, -1. Make that a little cleaner. So we move this direction, right? So negative pi over 2. So we have 0, -1. And so the cosine value, of course, is the x, so it's the 0. But that means that 0 that's normally occurring at negative pi over 2 is now occurring at 0. Well, hold on. What did I just make? This purple piece looks a lot like a sine function. And in fact, that's exactly what it is. Sine of x is equal to cosine of x minus pi over 2. So this minus pi over 2 we'll call a shift, right? In this case, it shifted the cosine function to the right. Now remember, it always does the opposite. Normally we'd think, oh, well, it should be the left because you're subtracting. Yes, but in the argument, it always does the opposite. It shifts it to the right. And when you shift the cosine function to the right by pi over 2 units, you actually get the sine function. So this is how the two functions relate to each other. All right, that's it. If you have any questions, let me know.